So, good morning to all. To talk about the topic for that, important topics are the hybridization. Hybridization is a simple logic for that, and based on H. The representation of H is a number of sigma bonds plus a number of lone pair electrons. It's a simple logic for that. Easily analyze the hybridization of the compound with the perfect geometry, which was the applications of hybridization. Hybridization with geometry of the molecule or compound. For example, the topic of hybridization most important to the CSIR net and TRB exams also, and easily the most of the questions talk about to that. Most of the questions are asking in TRB for the tabular column. Match the following or tabular methods. For example, how to find the H hybridization is find the equation for that. Simple logic: number of sigma bonds plus number of lone pair electrons. For example, hybridization value becomes to H, the representation of number of lone pair electrons, number of sigma bonds. You can dig the geometry, the shape, which is the shape of the compound, shape of the molecule or compound. In first one, I like that Sp, hybridization becomes to Sp. It means that the total value becomes to 2. The number of lone pair electron becomes to 0. Number of sigma bond becomes to 2. The geometry of the compound becomes a linear. Geometry of the compound becomes to linear. The shape like that scale like structure. For example, this type of molecule. For example, A, B and B. That is an example for that. In case of hybridization for sp2 becomes the total value of H becomes to 3. The number of lone pair electron becomes to 0. The number of sigma bond becomes to 3. The perfect geometry of the compound is represented for trigonal planar. The shape of the compound, this one. Trigonal planar becomes this one. For example, like example for the BF3 like of compounds. And then the geometry becomes to sp2. The total value becomes to 3. The number of lone pair electron 1, and the number of sigma bonds becomes to 2. The total value becomes to 1 plus 2 becomes to 3. The number of sigma bonds plus number of lone pair electron is becomes to 3 values. The geometry of the molecule becomes to angular or V shape or bent or inverted V. The molecule becomes to this one. The one lone pair and 2 bonding orbitals is a sigma bond. It also a sigma bond. In totally for that 2 sigma bonds, 1 lone pair electrons. And then next hybridization for that sp3. The total value becomes to 1 s orbital, 3 p orbital. Total becomes to 4. That means 1 s and 3 p. The total for 4. Then the number of lone pair electron becomes to 0. The number of sigma bonds become to in 4. The perfect 4. That becomes a compound becomes a tetrahedral. We know that shape of the geometry of the compound. We know that the TD structure. And another type of sp3 becomes to that in 4. The representation for 1 lone pair electron and 3 sigma bonds. In total becomes to 4. The molecular formula of the compound becomes to, it's a pyramidal structure. For example, the sigma, sigma and sigma, the one lone pair is a one lone pair electrons. In another type of sp3, it also if total value becomes to 4, 2 lone pair electron and 2 number of sigma bonds, 2 lone pair and 2 number of sigma bonds. The molecule becomes to structure for that, the geometry of that angular or V shape or bent structure. The representation for sigma, sigma is the molecule like that water example, like that water. For this molecule example for that ammonia, this molecule example for methane, like that similar geometry, sigma and geometry and shape. The H value represent that in H represent by the 4 in sp2d. The H value represent for not present in this compound. For example, d in absence of d, not like that, but another type of compound, the sp3d. The sp3d lone pair electron becomes to 0 and sigma bond becomes total value 5. Then 1s, 3p and 1d. In total for that 5. The geometry trigonal pyramidal structure. For example, this one. For example, sigma, 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 sigma and sigma is a trigonal pyramidal structure. And another sp3d with 1 lone pair electron and 4 sigma bonds. I like that seesaw structure. Seesaw model. For example, this one. Seesaw model. Another type in sp3d and 2 lone pair electron, 3 hybrid orbitals. The tabular is most important to that. The geometry of the compound is a T shape. That's a compound. The 2 lone pair and 3 sigma bonds. For example, this one sigma, another sigma bond, this one. The 2 lone pair electrons. That's a very important conclusion for that. 5 hybridization values. The next type of the compound for that sp3d with 3 lone pair with 2 bonding orbitals. You like that is a molecule like for that linear. For this, like that. So 3 lone pair electrons, this point 1, this point, it's a sigma bond and sigma bond, 3 lone pair electrons, so 3 lp plus 2 sigma, in total value for that 5. Okay, and then the next type for that 5 coordination numbers, dsp2 in total becomes to for that in 4 values. dsp2 becomes a 4 values in 0 lone pair electron and 4 sigma bond. The d present in the first that means inner bonding orbitals for the d orbital in square planar structure. For example, perfect square planar structure. That's all. The 4 atoms in square planar structure. Okay, sp2, dsp2, and then it's very important to that sp3 d2 and d2 sp3 in both are 6 coordination values. With the absence of lone pair electron and only presence of 6 sigma bonds in perfect octahedral. For example, this point. That's a perfect octahedral. I give the best example for SF6. Or any other molecules, for example. And then the next type of for that in sp3d2 with 1 lone pair and 5 sigma bond, the compound presence of square pyramidal or disordered octahedral. The structure of the compound 1 lone pair electron this point. In totally 5 centers for the sigma bond and 1 lone pair electrons. And then next type of hybridization, sp3d2 in 2 lone pair electron in 4 sigma bonds. In total compound of the structure is a perfect square planar. Okay, square planar, but total hybridization becomes to 6. It not easily understood that, for example, most of that compound, most of the students or most of the examiners or attend to the compound, so like 2 lone pair electron with 4 sigma bonds, they must predict the answer for the octahedral, but the perfect answer becomes to square planar complex. For example, this square planar compound, not for a complex, this lone pair electrons. So we should analyze that easily for them, lone pair electrons with the sigma bonds. Okay, that's a good example for them. Another type of compound is sp3d3. In total hybridization becomes to 7 in absence of lone pair electron in 7 sigma bonds, and easily understood that this compound becomes to pentagonal bipyramidal. Pentagonal bipyramidal. I like that best example for that HF7. The geometry of HF7, this one. The 5 planar center, this one is topper and the middle of the plane, upper plane and lower plane of the structure. Total bond becomes to 7 sigma bonds. And then in sp3d3 with 1 lone pair electron plus 6 sigma bond, the representation for pentagonal monopyramidal. And easily understood that compound, the geometry, the perfect shape of the compound is a pentagonal, this pentagonal monopyramidal, this one. As I clearly explained that based on a lone pair electron, most of the TRB questions are polytechnic TRB or a PGTRB and CS net questions, and most asked to that in the basic simple logic for that. In last classes, most of that tabular column utilization of to find the hybridization of the compound by using that examinations, for example CSR net or PGTRB or polytechnic TRB questions, but easily understood or easily find that some of compound, for example xenon oxyfluorides, xenon oxy compounds are more than chlorofluoro compounds, iodine I3, any compounds are not easily find that hybridization. But I think I can clearly explain the shortcut methods for that hybridization by using the previous tables. For example, you must conclusion about to that hybridization in presence of previous tables, very important. You must follow that process in previous tables. For example, to find the shortcut ideas only for this, but in most of the geometry prediction from previous tables also. And now simple logic for that, and bust the explanation for that prediction of hybridization. The first one compound like that, xenon fluorides. The xenon fluorides, for example, in most of the noble gases family, for example, most of the examination for that xenon compounds are most repeated questions for that any examinations. For example, xenon compounds for that xenon fluorides, the valency of xenon becomes to NS2 and NP6, general formulas, not for the number of orbitals is not necessary, but NS2 NP6, the total valence electron becomes to 8. The shortcut methods to only follow that methods. In total 8 electrons will be put in the forms. The total 8 electrons put in the forms. The number of surrounded atoms, for example, is a central atom, is a surrounded atom. Central atom and then surrounded atom. the number of central atom becomes xenon. That's a very important to that. And we must predict that total valence electron of the central atom and then surrounded atom. So surrounded atom in the each fluorine sharing for the one electrons. For example, this fluorine and this fluorine. So remaining electrons will be paired. For example, these are paired. Is a lone pair electron, is a lone pair electron, is a lone pair electron. Totally, xenon fluoride content contains 2 sigma bond plus 3 lone pair bonds. 3 lone pair. In total value becomes to 5. Total value becomes to 5. We must predict the formulas. For example, total mean 5 means sp3d is a general formula, general step for that. 1 s orbital, 3p orbital and t orbital becomes a 5 values. It's also represent for the 5. We know that the geometry will be prediction from the previous tables. Easily prediction for that previous table. sp3d with 3 lone pair electrons is the geometry of the compound becomes to linear. The geometry of the compound becomes to linear. For example, xenon and fluorine, so 3 lone pair electrons. That's all. That's a simple logic for that xenon fluoride compounds. Like that, and second compound becomes a xenon F4. Easily idea for that. In most of the questions becomes to match the following. Xenon compounds or any difficult compounds in the match the following. In easily shortcut for that this way. And xenon fluoride compounds. For example, xenon becomes to central atom is a surrounded atom. For example, valency of the xenon becomes to 8 electrons. Is a valency. Surrounded atom becomes to 4 fluorine atoms. Each fluorine shared for 4 1 electron. In totally is a totally 4 sigma bond and is a lone pair. Is a 2 lone pair. In totally XeF4 contains 4 sigma plus 2 lone pair. The total value becomes to 6. The 6 mean sp3d2. The 6 mean sp3d2. But sp3d2 with 2 lone pair electron becomes a prediction table. Previously I told that prediction from the table in easiest compound for that square pyramidal. So not for square planar, square planar. For example, we know that the compound Hexe F F F F. That's all. So it is a square pyramidal structure. In simple logic prediction for that, the formulas base. And then the next very important toughest compound like that xenon O2F2. Xenon O2F2. For example, central atom Ca becomes to xenon, valency 8 electrons. Surrounded atoms 2 oxygen and 2 fluorine. For example, O2 minus. For example, 1 fluorine, 1 fluorine. Oxygen pairing for the 2 electrons. So totally this one, this. Okay. The each consideration for the 1 sigma bonds, not for the double bond consideration. The each one is carried for that 1 bond consideration. That means in totally 4 sigma and 1 lone pair electrons. Total values becomes to xenon oxyfluorides and 4 sigma plus 1 lone pair in total value for the 5 and mostly sp3d with 1 lone pair. The hybridization of the compound, it is a seesaw structure. Seesaw model. What do you mean that seesaw model? Xenon the seesaw model becomes to this method. In fluorine double bond O one lone pair electron. This model, seesaw model. The next, very difficult to that, xenon oxides. So seesaw model, lone pair the hybridization becomes to sp3d, seesaw model. The next hybridization for xenon oxides is a central atom, is a surrounded atom. Xenon valency becomes to 8. Okay, and then surrounded atom becomes to oxygen. Is a oxygen and 3 oxygen paired. The remaining becomes to lone pair electron. So xenon oxide fluoride content 3 sigma bonds plus 1 lone pair. In total value becomes to 4. So 4 becomes to sp3. 4 becomes to sp3. sp3 with 1 lone pair. With lone pair becomes to is a pyramidal. Pyramidal geometry. The pyramidal geometry becomes to that xenon, 1 lone pair. That's a clear formula for that and simplest explanation for the compound. The next, the very toughest compound like chlorine based or halogen based central atoms. Halogen based and easily compound to the explanation for that another type of compounds in easily. For example, the another compound becomes to IF5. IF5. The simple logic for that. The simple logic for that, central atom equal to iodine, surrounded atom equal to 5 fluorine atoms. 5 fluorine atoms. The valency of iodine becomes to NS2 NP5. In totally 7. To put on the number 7, this method. Okay, in surrounded atom equal to 5 fluorine atom. 1, 2, 3 and 4 and 5. In totally 5 sigma is a 1 lone pair. 1 lone pair. Totally IF5 equal to 5 sigma plus 1 lone pair equal to 6. The hybridization becomes to sp3d2 with 1 lone pair is a square pyramidal. Square pyramidal is a monopyramidal. Square monopyramidal like that, this form. In iodine, F, F, F and F, that's 1 lone pair electrons. This one. Okay, square monopyramidal forms.